Dear friends, today we will discuss various methods by which we can prepare pyrrole and its derivatives. So let us quickly start with the methods by which we can synthesize pyrrole. First, we will discuss preparation of pyrrole. Okay, so we know what is pyrrole. I have already discussed with you its structure in my previous lecture. So this is the pyrrole. Better to write as it is resonance stabilized, so this can be represented like this. So the first method of preparation of pyrrole is from acetylene. Acetylene means propine. So if we react propine, or we can say acetylene through and ammonia through a red hot tube, then pyrrole is formed. A mixture of propylene and ammonia, when it is passed through a red hot tube, then we get pyrrole. So this is pyrrole which is formed, plus hydrogen gas is released in this process. So this is one way by which we can prepare pyrrole. Now the second method is by which we can prepare this pyrrole is from ammonium mucate. Ammonium mucate. So this compound CHOH, CHOH, better to write like this, CHOH, CHOH, then again CHOH, CHOH, and then we have this ammonium salts at the terminal NH4 and COONH4. So this is your ammonium mucate. This compound is ammonium mucate. When this compound is heated with glycerol at around 473 Kelvin, then we get I am not discussing mechanisms here. I am just wanted to convey the various methods by which we can synthesize pyrrole and its derivatives. So this is first is from acetylene, second is from ammonium mucate. Now let us come to the third method by which we can prepare pyrrole. It is from succinimide. From succinimide. So let us write the structure of succinimide first. CH2, it is a 5-membered cyclic amide, we can say. This compound is succinimide. So when we distill this succinimide on zinc dust, this succinimide on distillation with zinc dust, it simply produces pyrrole, and zinc oxide is byproduct. So that is another method by which we can prepare pyrrole. So I am just, you can see, I am just writing the methods by which we are directly getting pyrrole. Now the next method is we can also prepare this pyrrole from furan. So we have discussed furan is a 5-membered heterocyclic compound with oxygen. So this this compound is furan. So when it is we heat a mixture of furan and ammonia, and in the presence of steam on alumina, this Al2O3 is called alumina at very high temperature, around 750 Kelvin. So alumina, it acts as a catalyst. This is a catalyst. Then we get, this is important method to prepare pyrrole from furan, because this method is used in the industrial manufacturing of pyrrole, manufacture of Pyrrole. This particular method is used in the manufacturing of Pyrrole. So these are some methods by which we can get Pyrrole. Now we will see is some methods in which we can prepare Pyrrole derivatives. These are very important methods. Preparation of Pyrrole derivatives. So first method in this category, and these are name reactions, so these are very important reactions. Paal, Knorr synthesis. So this method is used to prepare Pyrrole derivatives. Here we basically use 1,4-dicarbonyl compound. These are used in synthesis of Pyrrole. Basically this CH2, so C double bond O, C double bond O, CH3, or you can simply write it like this: CH3, C double bond O, CH3, C double bond. So now you can see these are 1 2 3 4 1,4-di carbonyl compounds. Basically when we heat them with ammonia and heat, if we heat these 1,4-dicarbonyl compounds with ammonia, or we can also use some primary amine instead of ammonia, some primary amine can also be used. So what we get is, we get a Pyrrole derivative CH3, it is 2,5-dimethyl pyrrole plus water, 2,5-dimethyl pyrrole. So the method is quite easy. It is a series of nucleophilic addition reactions and dehydration reactions. If we see how very quickly, it is not a detailed mechanism. I will just write some steps which will help us to understand how this reaction might have occurred. So we know that these carbonyl compounds, they undergo nucleophilic addition reaction with ammonia. So the first step is same. If we treat it with ammonia, then the first step is nucleophilic addition reaction, and what we get is, I am specifically writing in this way because it will help us to understand how it might have occurred. So again, this is a typically nucleophilic addition reaction of ammonia here. So we get this NH2OH here. These mechanisms we have discussed in our carbonyl compounds, where we discussed the aldehydes and ketones. We have discussed these reactions in very detail. So the next step is now dehydration. This hydrogen and this OH, there is a loss of water, minus water. So what we get is CH double bond C, CH3, CH2, C, CH3 double bond O, N, H, so it has a lone pair. So you can see, if I have to write this, it contains two double bonds. So we need one now we have synthesized one double bond. Now what we need to do, we need to close this ring, and we need a double bond here. So next step is quite evident. I am sure all of you might have understood. Now this is a nucleophile and this is electrophilic carbon. Now it can attack here, this ring closure reaction. So this is the ring closure reaction. So what we get is, I will write on the next page, this is a nucleophilic addition reaction, and here ring, we are getting a ring, that's why I am calling it ring closure reaction. Okay, so what we get is CH, again this is just to show, I have written it like this because I have to show the removal of water. CH3, CH3, now upon reaction, this ring closure reaction, it has given us this. So the next step is clear again, removal of water minus water, so what we get is we get a Pyrrole derivative 2,5 dimethyl Pyrrole. So 1 2 3 4 5 2,5 dimethyl Pyrrole. So this method is called uh, Paal Knorr synthesis. Now coming to next, again very important method by which we can prepare these Pyrrole derivatives is Hantzsch HANTZSCH. So Hantzsch Pyrrole synthesis. In this reaction, it is basically a condensation reaction between alpha haloketone, condensation of alpha haloketone. So you can remember this tagline, like in this name reaction we have to react, one reactant is alpha haloketone and the second reactant is with a beta keto ester. Okay, and we need now here, so you can see there is no hydrogen, so hydrogen will come from ammonia in the nitrogen in the presence of ammonia, or instead of ammonia we can also use primary amine. Okay, so let us see how again alpha haloketone with beta keto ester. First, this beta keto ester, so the first step will be reaction of this beta keto ester with ammonia. So let us see, let us write on the next page COOC2H5 CH2 C double bond O CH3. You can see this is an ester group, this is alpha position, this is beta position. So this is beta keto ester and this particular ester is ethyl beta keto butyrate. Now upon reaction with ammonia, now again reaction is similar to the Paal-Knorr synthesis. It will react here. We get this COHNH2, then there will be removal of water, OH from this carbon and hydrogen from here. So I will just write, okay, so that basically minus water will be released. What we get, COOC2H5 CH double bond CNH2 CH3. So this compound is called ethyl beta. Now we have amino, ethyl beta amino but 2 enoate. This is our enoate, but 2 enoate. Again what might have happened, so this might have attacked here nucleophilic addition reaction. What we would have got OH and NH2. Now this hydrogen from here and OH from here, it might have resulted in loss of water and we might have got this. Now this compound react with our second reactant, which was alpha alpha haloketone. Again now this compound COOC2H5 CH double bond C CH3 NH2, it react with CH2 ClCO. So I am taking here alpha chloroacetone. This is our alpha haloketone. Okay, this is ketone, this is alpha position, we have a halogen at alpha carbon, so alpha haloketone, and this particular compound is alpha chloroacetone. Now HCl is removed and water is removed, so basically then there is a ring closure reaction, removal of HCl and removal of water. So we get here is C C H C C H, this carbon C C H, double bond C C H 3 NH C, double bond CH CH3, and here we have with this carbon we have this group COOC2H5. So this method is called Hantzsch Pyrrole synthesis. This group can easily be removed after first hydrolysis. It will be converted to carboxylic acid, then upon heating and decarboxylation. Okay, upon decarboxylation this will give us hydrogen. It has to undergo a series of reaction to give you this 2,5-dimethyl pyrrole, but this is again a as we are synthesizing pyrrole derivatives. Okay, so the last and the next method that I will be discussing with you will be Knorr pyrrole synthesis. This is the most commonly used method, most commonly used method for the synthesis of pyrrole derivatives. In this reaction, this is again a condensation reaction of alpha amino ketone, condensation between alpha amino ketone derivative with beta keto ester, beta keto ester in the presence of acetic acid. Acetic acid, basically CH3 C double bond O, CH COO C2 H5 NH2. This is our alpha amino ketone, and this compound is ethyl alpha amino beta keto bitrate, beta keto bitrate. This on reaction with beta keto ester. So in the presence of acetic acid, there is removal of water minus 2 water molecule, and what we get is, I will simply write the final product. So these are, as I have told you, I am just giving you an overview here by which we can synthesize pyrrole. So we can discuss the mechanism some other day in detail, one by one. Here my intention is just to tell you the various methods by which we can synthesize pyrrole and its derivatives. So these were some methods of synthesis of pyrrole and its derivatives. So thank you very much for your kind attention. In the next lecture, similar to pyrrole, we will see how we can prepare furan. Okay, thank you.